Hi all, thanks for coming on and joining the presentation on Advanced Framework Extension, also known as AFX. So we're going to cover, what is Advanced Framework Extension. We're also going to talk about top-down design and using skeleton models to control geometry, the placement of, or the position of geometry, dimensions, scale, that kind of thing. And then we'll get into a demo, and then we'll have a little bit of time maybe for some Q&A. So my name is Bill, and I am a technical specialist here at PDSVISION North America. I've been a technical specialist technically at PDSVISION for 3 years, but I also worked at Boundary Systems for another 2 or 3 years. So I've been in this kind of technical specialist role for, at least, the last 6 years or so. I also have a specialty in industrial design, and I'll briefly kind of just switch to some of my work that you can see here. So I'm really into like sculptural design, these designs that have a high degree of curvature, kind of organic in shape. So I'm really into like digital sculpting as if you were using clay in a sense. So that's my bag. So what is Advanced Framework Extension? So it's tailored to mechanical and plant engineers who need to create structural frameworks. And you can see the image to the right. My first 3D printer was a Creality Ender 3 S1. So that's the 3D printer that you see in that 3D printer enclosure right there. And all the framework for that was created within Creo. And the render that you see in this image was done in KeyShot. What's nice about the Advanced Framework Extension is that it allows you to create framework extremely fast. There's a component library with different tubes, connectors, different plates. You can see that I have wheels down there that I added. There's even stairs. If you create framework, if you create fixture assemblies or something too, if you're in R&D, this is a really great tool for you to rapidly create these frameworks. And you can see that it actually allows you to create them up to 10 times faster than traditional techniques. It's best driven from top-down design. So for those of you that don't know, top-down design as opposed to bottom-up design, which forces you to create a bunch of components, then assemble them and make sure they fit together. Top-down design is a way of using a skeleton model, or it could just be a Creo component at the top level of your assembly to create the sketches, datums, surfaces that you need to control your individual parts in an assembly. So it's a central place of truth. Usually there's a management team. It could be the manager of the engineering team, for example, and maybe one of the other top engineers that get together and say, hey, we want to use this top-down design approach. Let's get together and talk about what datum, sketches, references we need in that skeleton part, so that we have the correct information there, so that if we do have to make a change and have it trickle down and filter through all the components so they update the way that they're supposed to without any failures. Let's make sure that we get everything there and take the time to set this up so that when changes can be made, it's seamless. There's no issues, and it's fast. So we're going to talk about that a little bit today, and you'll see it in the demo. All right, so again, talking about top-down design and how it's used with AFX. You can control your framework design using top-down design. You're consolidating important design information about geometry and skeletons, dimensions, and potentially notebooks. Notebooks are a nice way to also control your assemblies with top-down design. We're not going to get into that today, but if you want to learn about those at some point, you can reach out to our team. Once you get all the information that you need in that top-down skeleton part, you're going to share that information with the individual components. And then that allows you to manage the interrelationships between the components. And again, allows you to implement changes faster and easier. Because you can imagine if you're not using the top-down design approach, you're using the bottom-up approach, if you have 100 people that created 100 different parts, or maybe 1,000 or whatever, if one person makes a change to a part that's in that assembly, the impact it can have because of the associativity between that part and others can be huge. So you can change one part and have to maybe change, 10 plus additional parts from that one change. If top-down design is done correctly, you can avoid that and just make one change at the top level and have all the components update the way that they're supposed to. So one way that I use top-down design to control the framework for this 3D printer housing was using a skeleton model. But I also wanted to show that you can use relations as well. So for example, I have a relation there to the right where I'm basically controlling the width and the height of the door of the enclosure based on the width and the height of the cutout for that door. So I can show that a little bit. Okay, so I'm gonna get right to Creo now. And the first thing I'm gonna do is I'm gonna show the completed assembly here. So just to get like a lay of the land, we have the 3D printer enclosure, we have the framework that holds it up. And I've also created a little platform here so that I can add these stairs. These stairs were also added in the advanced framework extension. So at the top level, you can see I have my skeleton model. So, I took some time to develop the skeleton model because I wanted to show that, you can make a change here and everything else will update and everything else will remain in the correct place and that kind of thing. And then I also have the actual frame assembly. So that has the framework in it. It has this little platform with these I-beams that they're turned on their side, and it has the stairs. And then you can also see I have a plate the printer rests on. I have the printer assembly, and I have my glass here, plexiglass, and I also have my hinges. So these hinges here on that door. So I use a pin connection for this one, and I set a limit. And because of that, because I assembled the door to those hinges, right, you can see that I can easily, grab a hinge and open and close that door. Just regenerate that. I also have the door itself. I have this simple turn latch there to keep the door closed. And then I have my lid. Okay, so let's talk about the skeleton a little bit. So the skeleton model has a leg height control plane. So I can modify this plane to control the length of the legs. So here's an example. If I select the plane, edit my dimension, I can change this to 30. Regenerate that. There we go. So there it regenerates, it gets shorter. Okay, and notice that everything stayed in the correct position. So that's my leg height control. I also have my frame top sketch. So say that I wanted to control the width of this and make it wider, I can select that sketch, go to edit dimension. I can say, hey, you know what? Currently the width is 24 and the depth is 24. I can change the 24 dimension to 38. Hit enter, regenerate, and then regenerate again. Make sure that door is in the correct place. And now look what happened. Now it's wider, and I also have my hinges in the correct position. And then same thing again, if I want to change the depth dimension now, I can change this to 30, for example. regenerate. Okay. I can also control the location of the supports here. In the center, you can see that I have a datum point. It's called frame midpoint. So this midpoint was created along the sketch for the leg. So I have a front leg sketch right here. If I add a definition on that, you can see that I have the front leg sketch that goes to that printer base plane down to the top plane, how it's controlled. And then along the sketches of those legs, I also have this other datum point here, which is the frame midpoint along those legs. And then I basically created a datum plane on that point parallel to the top plane. So now if I want to control the position of that mid support, I can actually take that point, edit definition, this one here, edit dimension. I can say, hey, you know what, let's make this a little bit lower and change this, to 0.7 or something, regenerate, and now it's moved lower. Okay, pretty powerful stuff. All right, now there's also a relation here to control the door. So if I go to my relations up here in the ribbon, you can see that I have a couple comments here, and these comments aren't included in the relation. If they were, it would throw some errors. And if you want to write a comment to describe what a relation does, you can just do a /* and then you can type. So I have /* relations to control door parameter values. So this is what controls the values that I have down here in my parameters. I have a door cutout width, door cutout height, door width, door height. So these control these numbers here, my parameters. Then I also have relation to control the door dimension. So basically down here, I'm saying, this dimension D7-210, which is the door width, is equal to the door cutout width times 99.5%, essentially. And then the same thing for the height. And that's what allows me to get this gap that I want here in the door between this orange surface and this orange surface here, okay? What's really nice too is you can see that I have these stairs that I created, and what I can do is if I grab the stair plane right here and I adjust this, so right now we have it at 2 feet. Let's make this 4 feet. Regenerate. Look what happened. It added more steps. So by just changing the stair base plane and extending that further down and increasing that height, the advanced framework extension knew that in order for it to maintain those stairs, it had to add additional steps. I can always change that back and grab this guy and then change this, back to 24, for example. And the reason why I'm showing all this top-down design stuff is because, you can quickly create your different beams and connectors and elements to your framework by selecting a sketch, for example, or a sketch entity. But at the end of the day, if you're creating an assembly, your speed also should be coming from your skeleton model to make sure that you're not spending a ton of time making changes. So just wanted to make sure that I showed that here. Okay, so now I'm going to switch to here and we'll get into the advanced framework extension and showing how to create that geometry from there. So I currently have my assembly, which is frame 01. I'll activate that and expand it. So you can see that I have some components here that I already added, but I also have some that I didn't. So currently right now, you can see that you're seeing these blue lines, and those are the curves for my skeleton model. So again, I wanted to drive this geometry of AFX through a skeleton model, and that's why you're seeing these blue curves. Okay, so now in order to access the Advanced Framework extension, you need to go to your ribbon and look above the ribbon and find Framework. So if I click on Framework, it's going to take me to the Advanced Framework extension ribbon with all the different tools. I have a new profile. This allows me to search for different profiles for tubes, beams. There's also operations. If I want to reuse something, I can come here. There's also connectors that we'll take a look at. There's new equipment. So say, for example, I want to add wheels to this, which I will. We'll show that. If I want to create a joint between some tubes, I can do that as well. And that's basically, the foundation of this here. Okay, so let's start off now with looking for the profile that we want to use. So I'm going to go to New Profile, and I'm going to go to my section type here, and we're going to use the 80/20 inch 10 series profiles. So I'm not going to spend too much time on it, but I think it's good to talk about. So this 10 series folder that you see here is smaller out of the box. So for example, you can see that we have a P1010 that has these cuts on it. You can see all the cuts around the outside. And we also have this P1010S that doesn't have any cuts around it, right? So the profile is very similar, but it doesn't have the additional cuts that you see here in the P1010. So the 10S actually, and just want to give some props here to Alessandro Teodorescu, who is a technical specialist at PDSVISION. He is a longtime Creo user, 20 plus years, and he actually created this 1010S. And so this is a custom profile that he created. And the way he does this is he modifies, so he would take like the 1010 part, for example, here, because that once you use that profile, it has all the features in it that were used to create it. He modifies that. And then if I go to the folder right here, you can also see that, he had to create not only a 1010S part, but he also had to create a 1010S PNG. So if I open up that PNG, you can see that here. So he also had to create this, and you can see if we right click on it, go to properties, details, it shows the dimensions of the pixels, 150 by 150. And also note that the PNG name is the exact as the Creo part name, which is important. If you want to see that image in AFX, you want to make sure it's the same. And then you also have to have this list, which is a text file. And you can see here that, he has the 1010 part, the 10S part. So basically he has all the different parts that he has typed up here. And then he also has this directory _up directory. So you have to have this bottom line here for this to work. So after you spend the time like he did to create this library with the correct part geometry for the profile, the image file, and you have this text file, then you could just drop that in, and I'll just go back here again. This directory for AFX is, in this case, I have Creo 10.02, common files, AFX, parts, profiles, and then we went to the 80/20 inch 10 series folder and basically dropped these in. Pasted those in there, and then when you launch Creo, you should get all the new profiles that you see here. Okay, so just wanted to spend some time talking about how that was done. Okay, so because Alex took the time to create the 10S profile, I'm going to use that. So I'm going to select this one right here. Okay, and then you can see right here, it's showing the section type that we selected. All right, I'm going to click next. And then this window opens up here to the right. So this window is showing that, this is the size. The reference method, that's basically giving me an option here to determine which reference I use to place the geometry. So I can use, in this case, a curve. So I can use a straight edge, right? So up here, you can see I actually assembled this corner profile on an edge of the skeleton surface. And I'll show that later here. So in this case, what I'm gonna do is, I'm gonna select this sketch curve from my skeleton model, okay? And it's gonna place it there. I can also adjust position. So right now, if you zoom in here, you can see that there's a group called move. And move allows you to position your geometry relative to the curve that you selected. So right now I'm just dead center on it, but I can offset here forward, I can offset back, right? I can place the corner of the tube on that curve or switch to this curve, right? So you can orient this thing, whichever way you need using these buttons. I'm gonna put it center so that this skeleton curve is directly center to the hole. You can rotate the profile, and this goes for most of the profiles, not just this one. I can rotate that 90 degrees if I wanted to, 180 degrees. So what I'm gonna do is I'm gonna go ahead and click OK and close. And then notice here it added this AFX PE frame 1 P10S, but notice it doesn't look, this is like a simplified version of the geometry, right? So if I want to get the actual geometry, I can activate the part and I can resume these cut features and rounds. So I'll just shift select and resume what's suppressed. And now you can see I get that geometry that you saw in the profile list for the 1010 series. Okay. And what's great about this now is if I go back to my frame assembly, subassembly level, and go back to framework, you're not going to want to create new part numbers if you're using like the same lengths, for example. So if this vertical support leg here is going to be the same for all of them, which it should be, you can just reuse that profile. So if I go click on the part and I go to reuse, I can click next and I can select that curve. I can repeat, select that one back here again. I can repeat and select this one. Okay, and then click OK. And then close. So now if you look down here in the model tree, you can see that we have the same part numbers, right? We have 10S14, 10S14. All four of these are 10S14. Okay, and then same thing here. Now I'm going to go back to my profile and I'm going to create the horizontal beams here, right? Now notice that, this is a little bit higher than I want. I want to shift this down so the top surface of that is, flush with the top surface of the vertical. So I'm going to go ahead and go to top, which is the first row, middle column. And now it's going to be positioned where I want it, like that. Okay. And I'll click OK. And then again, I'm going to go to that part here and resume those features that are cut out. Okay, so you can see that the joint that we've created isn't ideal, but the good thing is that we have some options. So if we go to basic joints and select that button, you can see that a window pops up and we have different options, right? We have define joint corner, corner with gap, corner with overlap, miter joint. So if I want to take a look at a miter, I could select on miter, and then I could grab, this surface, for example, and that surface is automatically going to create that miter joint. Okay. I can also click the other options just to show it. There's overlap. There's the gap option. Right. There's the overlap there. Okay. So I'm going to go back to miter. Right. And just show that. Okay. Take a look at that. I could also say, hey, I don't like any of those here. I want to cancel the joint that I created, and I can go to join one profile N to a profile, do a T joint. So I can select this guy right here, grab that end in this surface, right? And now I got my T joint. All right, so let's just take a look at some options, now that we're here. So I'm going to go back to my profiles just because I wanted you to be able to see what other profiles exist. So we showed, this, square 2 profile, this 1010S, but there's many others, right? You can see that I have a curved profile that I use for the printer housing on this edge. But there's, if I go to steel beams inch, you can see that we have round beams, rectangular tubes, we have I-beams. I actually use an I-beam down here for that platform. T-beams, we have, sheet metal, channel beams, different profiles here, control dynamic. I mean, there's so much in here. I mean, you could literally spend, months experimenting with the options that you have here. Okay. So now let's take a look at connectors. So I'm going to go to my new connector element, and let's take a look at what we have. So I'm going to go back to the 8020, and I'm going to go to my see here, 10 series, here we go. And I'm going to find a bracket. So I'm going to grab this 4136 bracket, click next. And then now I'm going to come in here and say, hey, you know what? I wanted to go from here, that surface, to this surface, and there it is. Pretty quick. All right. I can choose a different one if I wanted. If I wanted to use this style of a bracket, I can do that as well, right? And I could click here and here, create that. And just to show you, what else is in here as far as connectors, there's a bunch, right? So we have end fasteners, anchor fasteners, steel construction, we have bracing plates, we have flexible joints if you need that, cubic connectors, if there's a gap between your framework in the corner there, other style brackets, different sizes, screws, so there's fasteners here as well. I mean, you could just go on and on. There's just so many. Okay, so now I also want to take a look at some new equipment. So in the equipment, there's a lot to choose from. So for one, say that we wanted wheels at the bottom of this thing, we can do that as well. So let's go ahead and find some wheels. That's going to be in the item folder. And then we're going to go to wheels, and I'm going to use this Caster D75 swivel double brake. Click next. All right, and it's going to ask me for an axis. And the surface to assemble to. Right, and there's the wheel. And just like any other part, that you've assembled in the past, you could adjust the position. So if I wanted to, I can just find that wheel. I can edit definition on that. Maybe I want to turn it. So you can see that I have the axis constraint here, right? I can deselect the constraint enabled, and I can just rotate this to position it, where I want it like that. Okay. Re-enable the constraint. There's also feet. So if I go in here to my new equipment, I can go back to item, feet, and I can find and use one of these feet. Maybe I'll use the D30 right here, and I'll find the axis and place the foot there. All right. Maybe I want a handle. So if I have to lift this framework at some point, right, it would be nice to have a handle. Well, I can find that here. I can go to my new equipment, control dynamics, doors and floor, go to handles, find the profile that I want here, and then it's going to ask me for a face to place the handle on. It's going to ask me for offset surface here. I can preview it, and then I can adjust the offset. Maybe it's negative a number and do a preview. Looks good enough. So now I've got a handle there. Okay. I can also add stairs if I want. So that's a steel construction inch, stairs, stair 1. And in this case, let me turn my datum planes on. Right? So it's gonna show you in this image these numbers, and those numbers are associated to the reference that you're going to select for the placement of the stairs. So the first thing it needs is a bottom plane. So we'll use a stairs bottom plane from the skeleton model. It's going to need a top plane. I want the stairs to go up to this platform surface, so I can select that. It needs an attachment plane. Maybe I'll use this surface here of that I-beam. And it's also going to need a center plane. And I'm going to use the right plane here, and I can preview that. And now I've got stairs. And again, if I adjust that plane in the skeleton model, stairs bottom surface, and I modify that from 2 feet to 3, for example, we should go, you do that again. Make sure I get out of this and go back to top level assembly, make sure it's activated, and I'm going to find that plane. Let's do 48. And there it is. So now it's 4 feet, and now we have these 4 steps, right? It's pretty neat. Now, going back to the creation of these tubes, we looked at using a curve, but you can also connect using points. So for example, if I want to create another profile here, and let's use that 1010 series, I'm gonna go next. I can change the reference placement method to points instead of curves, and I can choose this frame midpoint down here, for example. And I meant to actually select, let me curve. It looks like I got it. So I went from point. Let me actually try to get back here to that and do it again. So I'm going to grab that 0.0 there and the frame midpoint. There it is. Okay, now I got from point to point. Perfect. right? And then here again, if I wanted to, I could then trim this. So I can go to advanced joints. If I just want to trim this thing off using a surface of one of the horizontal tubes as a reference, I can go to advanced joints, right? And I can basically say, hey, I want to do a planar trim. I want to trim this with this, and now that's trimmed to where I want it. And I can keep on doing, I can repeat, and I can trim this surface to that surface, right? So you can kind of keep trimming it there to get that where you want it, okay? All right, so I'm gonna switch back here to the other assembly just so that you can see it, and talk briefly here for a second about KeyShot. So for those of you that don't know, KeyShot is a powerful tool that allows you to create realistic renders of your assemblies, your products. And what's nice is there's actually a KeyShot plugin. So if you look at the top of my Creo window, there's a KeyShot button. So I can render directly from Creo to KeyShot. And if I make any changes to my assembly and I click on update, those changes will be reflected within KeyShot. So here's KeyShot here, and here's a rendering of the framework there as well. Okay, so that brings me to the end of the presentation, and I guess I'll leave it open for questions. All right, so it looks like there aren't any questions at this point. Just want to make sure that you guys know that you can contact me at any point. If you're interested in anything Creo related, please contact me. You can see my email, bill.drosos@pdsvision.com. You can also contact sales. Please reach out to us. We love to help. We love to see what companies and individuals at companies are working on, what challenges they're facing, and we just love to problem solve. So thank you guys for joining the webinar, and hope you have a great day. Thanks a lot. Bye.